Welcome to ChemExam Explained, where the aim is chemistry clarity, exam mastery. In this video, we will be looking at Cape Chemistry Paper 2, Unit 1, Module 2, 2025. Let's begin. Question 2, Part A. A mixture of hydrogen gas and iodine gas is sealed in a glass bulb and placed in a thermostat bath. A dynamic equilibrium is established at 450 degrees Celsius. Part 1. Describe the four characteristic features of this dynamic equilibrium. Four examples that we could use out of five are: macroscopic properties are constant, microscopic properties are continuous, equilibrium can be established or achieved from any direction, equilibrium can only be achieved if the system is closed, and, according to Le Chatelier's principle, if a system is in equilibrium and a change in concentration, temperature, or pressure occurs, the system will act in such a way to oppose the change and return to equilibrium. 2a Part 2. Write a balanced chemical equation to represent the reaction described in 2 Part A above. Here we have hydrogen gas plus iodine gas with your reversible arrow to produce 2 hydrogen iodide. And this is your equation for 2 marks. Put in your state symbols and ensure that you have your reversible arrow. 2a Part 3. It is more convenient to measure the pressure of gases at equilibrium rather than concentrations. Table 2 provides information on the analysis of the equilibrium mixture of the gases at 450 degrees Celsius. So here we have Table 2, and we have our equilibrium pressures, or partial pressures. For hydrogen, we have 2.5 times 10 to the 4. For iodine, we have 1.6 times 10 to the 4. And for hydrogen iodide, we have 4.0 times 10 to the 4. So we write our partial pressure expression from our equation that was written in Part 2. So it is the product, which is hydrogen iodide raised to the second power, over the product, which means the multiplication of the reactants. And they were not raised to any coefficient because their coefficient would have been 1 each. So we just simply write the equation for Kp, which is our partial pressure, and then we plug in the information. So for hydrogen iodide, you plug in 4.0 times 10 to the 4, and you square it. You get 1.6 times 10 to the 9. Then you plug in for hydrogen 2.5 times 10 to the 4. For iodine, you plug in 1.6 times 10 to the 4, and you multiply, and you get 4.0 times 10 to the 8. Then you do your division, and your partial pressure ends up to be 4. Now, there are no units written for the partial pressure here because the partial pressures would cancel out each other. 2 units above would cancel 2 units below. And so we have no units, and that is for 3 marks. B Part 1. Describe each of the following terms. Solubility product. Solubility product is the product of the concentration of each ion in a saturated solution of a sparingly soluble salt raised to the power of their relative concentration. Common ion effect. Common ion effect is the decrease in solubility of a dissolved compound by adding a solution of another compound that contains an ion that is common with it. B Part 2. Calcium phosphate is a water-insoluble mineral which is used to make commercial fertilizers. Given that the concentrations of calcium 2 plus ion and phosphate 3 minus ions in equilibrium are 2 times 10 to the 8th. They have 8th here, but it should have been 2 times 10 to the minus 8. And they have 1 times 10 to the 9. It should have been 1 times 10 to the minus 9. But I put in the negative for the 8 and the 9 here with these corrections. You are now to determine the solubility product, Ksp, of calcium phosphate. The issue I'm having with this question is that I would have preferred if they asked for the equation first before the calculation, because in order to do the calculation, you need the equation to be able to write the expression for Ksp. And so we write the equation first for calcium phosphate to produce 3 calcium ions and 2 phosphate ions, and they are aqueous while the calcium phosphate, being sparingly soluble, is a solid. Again, you must put in your reversible arrow. So we pretty much answered part 3, where they asked us to write a balance equation for the equilibrium reaction of the formation of calcium and phosphate ions from calcium phosphate. So that was done already. Now from that we can write our KSP expression, where we now have the concentration of calcium ions raised to the third power times the concentration of the phosphate ions raised to the second power. Now, you must know that these ions are already in equilibrium. So we are not going to multiply the value we get by 3 or for phosphate by 2, because this is already our concentration in equilibrium. So we just simply plug in the value and cube it for calcium, and then we plug in the values for phosphate and square it. And therefore we continue with our calculation. Ksp is now equal to 8 times 10 to the minus 24 times 1 times 10 to the minus 18. And our Ksp value is now 8 times 10 to the negative 42. And our unit is moles to the fifth, dm minus 15. How did we get that? We have 3 calcium ion concentration and 2 phosphate ion concentrations. So it's mole per dm cube times 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 mole per dm cube. 5 of them. Then you multiply the moles 5 times, you get moles to the 5th power. And of course, dm now is dm minus 3 times dm minus 3 is dm to the minus 6 times dm minus 3 is dm to the minus 9 times dm minus 3 dm to the minus 12 times dm3 dm to the minus 15. And that's how we got our unit, moles to the 5th dm to the minus 15. Part C. A saturated solution of silver chloride is filtered and the residue washed with dilute hydrochloric acid instead of water. Comment on the solubility of silver chloride in water compared with the solubility of silver chloride in dilute hydrochloric acid, and justify the difference, if any. The solubility of silver chloride is decreased in dilute hydrochloric acid than in water. The hydrochloric acid has the common ion Cl- ions, and this would decrease the solubility of silver chloride, forming a white precipitate. So this is dealing with the common ion effect. Part D. Write the steps in an experimental procedure for the determination of the solubility product constant of barium hydroxide. First, you would prepare a saturated solution of barium hydroxide solution. You would then filter the solution to remove the excess solid. After that, you would titrate about 25 or 20 cm cube of the barium hydroxide saturated solution with standard hydrochloric acid. And this is an equation showing the reaction between the barium hydroxide and hydrochloric acid to produce salt and water. After that, you would then determine the concentration of barium hydroxide solution from the result. The barium hydroxide would produce barium ions and hydroxide ions. After that, you can use that equation to calculate the Ksp using Ksp is equal to the concentration of barium ions times the concentration of hydroxide ions squared. Part E. Buffer solutions are used to provide suitable media for a variety of activities ranging from industrial to essential life processes. E Part 1. Define the term buffer solution. A buffer solution is a solution that resists changes in pH when small amounts of acid or alkali is added. Part 2. Explain how the molecular structure of amino acids relates to their function as buffer solutions in human blood. Well, we must first talk about amino acid. And as you can see, that amino acid consists of 2 parts, 2 groups. Here we have the acid COOH, and here we have NH2, which is the amine. So the first thing we say is that the amino acid contains the carboxylic acid group and the amine group. In solution, the amino acid exists as a dipole ion called zwitterion. So here we see where the acid donated the proton to the base, forming the conjugate base, COO-, and the base accepted the proton to form the conjugate acid NH3+. So now this is our dipole ion. which is our Zwitter ion. So this dipole ion will now interact with things in the blood. So if you add acid to our blood, then the H plus ions are neutralized by the conjugate base. And so if you look at the equation, you see that this part is a part that will counteract the increase in the H plus ions in the blood, forming this section which forms back the acid that was already there, leaving our pH constant. If alkali enters the blood, the added OH minus ions are neutralized by the conjugate acid, which is the NH3 plus group. And as you can see here, this group is what counteracts the OH minus ions. And so this should be minus. And this then, the conjugate acid will donate a proton to OH, forming water. And this again will produce something that's already present in our blood, which maintains a constant pH. Part 3. State one industry in which buffer solutions are used. And that is easy. That's our pharmaceutical industry. And we can think of things like eye drops, that when you put that in your eyes, it maintains a balance or a constant pH so that there would be no change in pH to damage your eyes. The lotions you put on your skin, the diaper rash that baby has, you use a powder that will maintain a constant pH and prevent diaper rash. And so the pharmaceutical industry is the answer for this question. This ends the question for Module 2, Unit 1, Paper 2, 2025. Thank you.